We looked at a pattern for these index laws. This particular one though, do you remember what this index law is? What do I do when I have a fractional index? Yeah, I do. Which way do the variables go? Goes to the root. Right? And then what happens to the power? Right. Okay. So I introduced a way that I kind of remember this, right? It's I think of what a flower looks like, right? And it seems kind of gimmicky, but hopefully it helps you remember it. I say, like, if you imagine this as a flower, this fraction, right? The top part, that's like the flower, that becomes the power. And then the bottom part, that's like a root of a flower, right? So that becomes the root that you're taking. Okay. But I think we can do a bit better than that, right? Because what does this actually mean? And when we get to tricky examples, it's very easy to muddle these up together. Let's just have a look at what a fractional index actually is. And we always want to use our other index laws to try and derive them a bit better. If I take something like this, 5 to the power half times 5 to the power half. Sam, when I have something like this, what do I do with the indices again? If I'm multiplying, yeah. Sorry, I add them together. So I'm going to get 5 to the power 1 here. Right. Do I know something where if I multiply two numbers together, I'm just going to get the number 5? What would that be? What number would that be? We usually have a phrase that refers to that. So multiplying two numbers together and I get 5. The square root, right? If you take the square root of 5 and you multiply by the square root of 5, right, you will get 5, that number. Okay, that's the number that we have. And we can apply this idea to any number or term. If I had 2 to the power 1 on 3 times 2 to the power 1 on 3 times 2 to the power 1 on 3, that's going to give me 2 to the power 1 if you add up all these terms. Okay, or you could say that that's the cube root of 2. Yep. Cool. But what happens when we have a fractional index where I have another number on that numerator there, right? So in, maybe let's take this case here. What if I had 2 to the power 2 on 3? What does that actually mean? What does that actually look like? Think about from here, how can you get 2 over 3 as a fraction, right? Because here, I've added them all up and I get 1. But what if I only want 2 over 3 there? What am I actually looking for? How much of those terms do I actually want? Joel, yeah?
2 to the power of 2 root 3.
Sorry, say that again?
So it's 2 to the power of 2.
Sorry, no.
It's
It's a bit hard to explain, right? That's why I'm going through it. Because when we look at something like this and we just memorize this rule, it can be trickier for later examples. I think you're on the right track though. Matt, you want to say something?
Just 2 to the power of 2 and then cube.
Okay, right. So we can actually break this up, right? Because 2 over 3 is a fraction. Okay. One way you could break up 2 over 3 is you can say that's equal to 2 times 1 over 3. Would you agree? Would you agree that that's the same thing? Yeah, I can split that up in that way. I haven't changed anything yet, right? So I can actually do that here. What I could do is I can say that this, I'm looking at the power now, right? I can say that that's the same as 2 to the power 2. Sorry, just give me 2 seconds. Times 1 over 3. But Eva, when do we multiply our indices? What rule is that one? Yeah, okay, when we multiply them, when we times them when we have that power to the power, okay, so that's in this case here. So another way I could write that is 2 squared to the power 1 over 3, okay, are we still following, right? All I've done is I said, okay, how can I break this up? I can break this up in this way, that's just 2 times 1 over 3, right? And then I can apply this index law, but I'm just going backwards now. Right? I'm going backwards, I'm saying, okay, let's put it back in this form. And then I can say, hang on, but this 1 over 3, that's saying I'm taking the cube root of something, right? That's what we established over here. It doesn't matter what's inside there. This 1 over 3 is I'm taking the cube root. So if I'm taking the cube root, then I'm taking the cube root of whatever's inside here, and that's 2 squared, right? So that's how we say, okay, this is the root, the one on the bottom is the root, and that power, that one on the top, that becomes the power there. Okay, does that clear things up a little bit, right? Hopefully you can see how that rule has been developed. Just some really quick examples. All right, let's just keep going through these. Okay, this first one here. When I'm looking at this, what kind of root is this one again? This is a square root, right? So that implies that there is a 2 actually here. So that's something that students always leave off, so I always mark that in. So that's the square root there. Then I know, okay, this is my root. So that goes on the denominator, and that's my power, so it goes on the numerator. So that'll be x to the power 5 on 2. Next one, can you help me out, Mick? What am I going to do for this one? Yep, cool, because that's my numerator and that's my denominator. So power is the numerator, root is the denominator. And it doesn't even matter when you get to questions like this, right? Because even though there's something that's a bit more complicated in here, always think about what you're looking for. You're looking for a root, which you have the 4th root. Emily, what's the power in here though? 1. Okay, so again, if we're just rooting, it's a few terms here, but the thing inside that root, that's all to the power 1. So I can write that as 8 minus x to the power 1 over 4. Okay. This one's a bit trickier though. Eva, what's different about this one? Okay, the 2 is separate. When I get to something like this, now there's a few ways you can actually write this out, but I kind of like to split this up so that I'm only looking at a situation like this over here, right? I can see there's a square root, and so I know that there is some kind of fractional index there. Maybe I'll write a little 2 there, right? But what I would like to do is I'd say, okay, this is essentially just half times 1 over root y plus 7. Would you guys agree? Right? All I've done is said that's just a half, and that's multiplied by 1 over root y plus 7. Okay, I haven't changed anything else there. But then I remember I'm combining index laws here. I've got the square root, which I know is going to be to the power half. Okay, but it's also on the denominator. So what else am I going to have? I'm going to have what kind of index? If it's on the denominator now, negative, right? So I've got half times y plus 7. So I know it's the power half, but because it's on the denominator, it's also going to be negative half there, right? And you could bring that together and you could just say that that's y plus 7 to the power negative half on 2. Cool. Any questions with that? No? All good? Last one here. James, how'd you go with this one? Yep. What did you try to do first?
First, I tried to get the negative power.
Okay. So which part did you start with? This part over here? So how did you rewrite that one?
I rewrote it as x squared plus 3.
Yeah.
For negative 4.
Negative 3 over 4? Yeah, right. Okay, so where did you write that? Because be careful when you're taking lots of steps at once. It can be a bit confusing. What I might do is I might just say, okay, let's rewrite this as x squared plus 3 to the power 3 over 4. Okay, and then if you want to take one more step, you could write that as a negative index. I'm not sure how the answer expresses it, but you could write it as this, right? So x squared plus 3 to the power negative 3 on 4. Because you know that that's actually on the denominator. If you want to write that with a negative index, then you get something that looks like this. Is that the answer in the back, Emily, by the way? Can you check 4J and 4M? Oh, really? Okay, how did they write it? Can you just check in the back for me? That's right, that's right. Okay, cool, yeah. So, again, it's a bit vague when they say rewrite in index form. Like, what do they mean? Like, is this in index form here because there's an index? Usually they want you to take it as far as you can, but you probably expect to take it one more step and write a negative index as well, okay?